we built the subscale reactor. Now we're talking about the calcium hydride storage system that we've worked on and we've got patents on, several patents. This is a viable technology near term, and it's 20 times the storage density of the nitrate salts that you see that they're developing for very large scale solar. And basically what we're doing is we're taking sunlight. Now this is a reactor where we're electrically heating it, but what you do on a large scale system is you put sunlight through a quartz window. There's a quartz window on this. The sunlight would heat a chemical reactor on the inside, and that would, by controlling the pressure inside the chamber and the temperature, you can break apart the calcium hydride into calcium and hydrogen. What happens is the calcium rises and floats on the top of the calcium hydride until you completely filled the chamber on the inside with calcium metal. The hydrogen gets pulled off, we cool it down, we store it in hydride containers, which are just lower temperature metals that absorb hydrogen safely. And then at night, when the sun goes down, so we reintroduce the hydrogen, and what that does is it combines with the calcium, gives off a huge amount of heat, and then we take that heat and use it to run the Stirling engine.
So it's your battery.
It's a thermal chemical battery, that's correct.
Right.
And for to give you an idea, a 100 kilowatt system, which would, this tank is about 2 feet in diameter and 3 feet high. A 100 kilowatt system that would power 4-cylinder version of the engine for 24 hours a day, continuous, would be about 8 feet in diameter and 10 feet high. So this one's used to do our experiments to verify that the system's running, that we're able to get the power densities, the rates, and really understand the physics of the calcium hydride reaction and all the metallurgy. Turns out we're using molybdenum on the inside of the reaction chamber to hold the liquid calcium at high temperatures. It's one of the few metals that works. So we're developing processes to make low-cost containers to hold the liquid calcium within this chamber. It's actually a triple wall chamber. There's an outer pressure chamber that's at room temperature. There's a middle chamber made of a stainless that holds the molybdenum chamber. So it's, safety is really an important thing. We're keeping that in mind so that if something was to spill, it would just stop inside the reactor and the reaction would stop. Also, calcium hydride degrades if it was to get released into the air into calcium carbonate, which is chalk. So very safe to the environment. We're not using any exotics or anything else that not only that you can't purchase, but that would be environmentally hazardous.
So this creates, okay, you've got a solar system on steroids then, basically.
That's right.
With a battery.
This is the battery, the chemical battery.
So you've got solar that while it's producing the solar, it's also producing the storage for the battery, right?
That's right.
And at night then it reverses and basically that storage moves back through. It's like a battery I've never heard of before.
It's a thermal battery.
Yeah. So, yeah. And it's obviously very efficient, huh?
95% for the 100 kilowatt, and for the 10 megawatt system it'll be 98%.
So then I think I heard that what, six hours of sunlight will possibly produce as much as 18 hours
of, right, so you can,
of storage of
that's right.
Wow. I mean, that's
the reaction rates are very high. Actually, we're looking at applications where you can take all the power out in 1 hour instead of 18 hours if you wanted to. In order to follow, let's say at night when everybody needed power for cooking or something, you need extra electricity, you could use this to tailor your load. There's groups looking at that because if you can sell electricity during the prime time, you could sell it for a lot more money versus at night where it's lower cost. So there's different markets you're going into with this. It's very versatile and it's very economical. To give you an idea, we can build these and get them into production for the same cost as pumped hydro, which is really the only economically viable storage system that people are using in the United States. So it's really a breakthrough in power storage.
Wow. Now, to try to explain, you've got the solar collectors, your big old plates, as you see. What do you call those?
The dishes. I have a model over here.
Okay. And then you've got that, and what you do is you send that heat through these, they look like satellite dishes, isn't that?
Well, I'll show you.
Okay, you'll show me. Okay, good. So anyway, what this is though, is this where you collect the intensity, right?
Right
Down
here.
to down this.
the window.
It's zeroed down through here, the intensity of the heat. And what did I see? It was something like 7,200 suns.
Yeah, 7,200 suns. These quartz windows will take 10,000 suns. You can pass that much heat, that much sunlight through that quartz,
Yikes!
and which is really a lot of energy.
Holy cow!
This is just half-inch
unbelievable.
stainless.
That's pretty massive. Okay, cool.